everyone, and welcome back to the Sky Tonight Star Show. My name is Nicole, and I'm a planetarium educator here at the Museum of Arts and Sciences. Now, I'm sure you were expecting Seth for this video, but I'll be taking over these star shows for the month of July as we focus on opening up the Lowen Planetarium again. So definitely check out our programs if you're in Daytona Beach. We have a lot of live shows similar to this one, as well as some other ones about the solar system and the universe. So let's go ahead and start talking about the summer constellations. So I'm going to speed up time a little bit, and we can start to look at the nighttime. Now, last week, Seth mentioned a popular asterism called the Summer Triangle, and that's going to be the focus of the show today. So I'm going to stop at about 10 o'clock. Now, this is good for the first week of July, and again later throughout the rest of the summer. Now, first, an asterism is a group of stars that make up a distinctive shape in the sky. Now, they're different from constellations, which are officially recognized patterns of stars. So this summer triangle asterism is made up of 3 bright stars in our eastern and northeastern sky, and they're from 3 different constellations here. So we're going to talk about each one of these stars and their constellations and some deep sky objects located in them as well. So let's start with the brightest star in this triangle, which is called Vega. Now, Vega is in the constellation called Lyra the Harp, and I'll draw the lines of that entire constellation here. Now, Vega is the 5th brightest star in the sky and is one of the most luminous because it is pretty close to us. So it's only 25 light years away, meaning that it takes light from that star 25 years to reach Earth, and that's, of course, traveling at the speed of light. Just to give you an idea of how fast that is, it's about 670 million miles per hour. Now, it seems pretty far away, but it's still closer to our sun's neighborhood than some other stars, which we'll discuss. Now, Vega is also a very interesting star because it will take over the title of North Star in about 13,000 years from now. So right now, the star Polaris is our North Star because it is closest to the North Celestial Pole. And that means when the rest of the stars appear to rotate over the course of the evening, the North Star will remain fixed and keep the exact same location. Now, it can be used to create something called a star trail photo, and it's very popular in astrophotography because you leave a camera shutter exposed overnight, and as the rest of the stars appear to rotate around it, Polaris is the only one that will remain in the exact same position. Now, as the Earth's axis of rotation precesses or wobbles over time, the position of this north here will change, so the star closest to the North Pole will change as well. And so Vega was the North Star in about 12,000 BC, and it will be the North Star again in the future, so the rest of the stars will rotate around this one instead. Because Vega also has a high luminosity, which is a measure of how much energy a star emits based on its size and temperature, it's pretty easy to find in the sky just because it's so bright compared to some other ones. So I would say if you're looking for the summer triangle, try to find Vega first. It's a very hot blue-white star, and that'll help you find the shape of the harp as well. Now we have one star of the summer triangle. Let's move on to the next one. Take a look to the lower right of Vega for the next brightest star in the triangle, which is Altair. Now, it is the brightest star in the constellation Aquila the Eagle, and it is the 12th brightest in the sky. Now, Altair is also pretty close to us. It's only 17 light years away. So if you look at that star tonight, you're actually seeing light that was emitted from that star 17 years ago. And if you think about that, every time you're looking into the sky, you're essentially looking into the past at what these stars used to look like, but they don't appear that way anymore just because of how long it takes this light to travel. And remember, it's still traveling very fast at the speed of light. It's crazy to consider that, but I think it's really interesting to think about how far away these stars actually are. So back to Aquila, you can see this eagle shape here with a star. Altair is at its neck. Now Altair also has a high rotation rate, which causes it to be very flat at the poles and not completely spherical. So it has a rotational period of 9 hours, meaning that it takes that long to rotate once on its axis, and that's pretty fast compared to our own sun, which takes 25 days for a complete rotation around its equator. Now to complete our summer triangle here, glance to the lower left of Vega for another bright star called Deneb, which is in the constellation Cygnus the Swan. It's the dimmest of the 3 stars in this asterism, but it's still the brightest star in the constellation. Now, Deneb is nearly 160,000 times brighter than our sun, but over 2,600 light years away from us, so it is outshone by the nearby star Vega, since that one is much closer to us. Now you can see this swan shape here with Deneb at the tail. And I'll also point out another famous asterism called the Northern Cross, and that's this section in Cygnus right here, which makes a cross shape. This constellation is home to many nebulae and open clusters, which Seth mentioned more in detail in last week's video. It also contains Cygnus X1, which is a strong X-ray source thought to mark the site of a black hole orbiting another star. Pretty cool. So there is an easy way to find 3 stars that make up the summer triangle: Vega, Altair, and Deneb. And I'll put up their constellation names as well. Remember, Vega is in Lyra the harp, Altair is in Aquila the eagle, and Deneb is in Cygnus the swan. I'll also put up the constellation art here. So now I want to move towards the northern part of the sky and talk about some other constellations which are pretty easy to find. And I'll even give you some hints for locating them on your own. So the first one contains probably one of the most popular asterisms that nearly every stargazer has heard of, and that is known as the Big Dipper. And that's part of the constellation called Ursa Major, which translates to the Big Bear. However, Ursa Major is a much larger constellation than just the Big Dipper itself. So there we have the entire shape of that greater bear. As you can see, the Big Dipper is just a small part of it. Now, this constellation is so large, it's actually the 3rd and biggest in the nighttime sky. And I like to point out Ursa Major and the Big Dipper especially because it's very useful for finding the North Star. So if you take the end of the plow here, it will point directly towards the North Star, also called Polaris. And that is part of the constellation called Ursa Minor, but you probably know it already as the Little Dipper. So like we talked about earlier, Polaris is called the North Star because it is closest to the North Celestial Pole, and you can see here it's above our true north cardinal direction. And that can be used for navigation because it will always point towards that north direction. And if we go later into the evening, I'll give you another easy way to find the North Star. So like we talked about earlier, you can see the rest of the stars appear to rotate around it, but Polaris is in the exact same spot. I'm going to stop right here. This is about 1:30 or so in the morning, so you don't have to wait up that late for it. But what you're looking for in the northeastern sky is sort of this W or M shape. Almost looks like a 3 in this direction, and that is the constellation called Cassiopeia. Now, this is another easy way to find the North Star. What you do is connect the ends of Cassiopeia here. You see it makes sort of a trapezoid, and you're going to draw a line straight through the center, and it will point towards the North Star. Now, it looks a little weird on my computer screen, but you can either find the North Star by using the Big Dipper pointing that way, or Cassiopeia pointing this way. Either way, you'll land right here on Polaris. So I only pointed out a few constellations for you to find on your own, but there are a total of 88 constellations, in the nighttime sky, and we can see about half of them from our point in the northern hemisphere. So we'll take a look how these move as we go later into the evening. And you'll see there's a lot more constellations that we didn't talk about today that you can still find on your own. So for this last little part of the show, I've turned off all constellation lines and those names, just so we can take a look at the nighttime sky without any interference. So this is what your night sky might look like if there were no light pollution in the area. You're able to notice a lot more stars and even get a glimpse of the Milky Way from our viewpoint inside of it. So as I wrap up this show here, I'll point out again the summer triangle, which was the main focus of this video. So we've got Vega up here, Altair, and Deneb. So those three form the summer triangle, which you'll be able to see for the rest of the season. Keep an eye out for those other summertime constellations, or even the fall ones. You might be able to start seeing those later in the evening. I wish you the best of luck and happy stargazing!